So, hey guys, I'm presenting today on some use cases in Georgia for alternative design that we've been starting to kick off. So, three takeaways for you guys today. The first is the alternative design tool allows for a lot of our subjective decision making that's being done to be just a little more data driven. It also allows benefit cost ratio to be gauged more proactively, particularly in those low volume environments without just observed crash data. And then third, the efficiency to complete this analysis makes it scalable. A lot of times, the analysis is just too complex to complete and prevents us from doing it and doing it in a data-driven manner. So the use case I'm showing today is some design variances that we had to do for a two-way left turn lane project in rural Georgia, District 2. That's kind of one of our more rural districts. Converting from 2 lanes in each direction, widening to add a two-way left turn lane. At various of these intersections, there was skew angles, you could call them. They weren't that skew, but they weren't up to standards with our policies, so we had to write a design variance for these locations. So originally, the design variance it said this in it. It said given the low frequency of crashes, no standalone improvements was needed at the intersection beyond the proposed installation of the two-way left turn lane on the main line. Well, we had some problems with this when reviewing that design variance. It was very subjective, low crash frequency. There wasn't anything specifying what that might be. Minimal data to support that decision, and nothing about proactive safety as well. So, we're trying to be more proactive. Just because there isn't a crash problem doesn't mean we don't want to do something to it. So we leverage the alternative design tool to gather some data on these corridors and make a more data-informed decision. So using kind of our project selection here on the alternative design tool, we added the intersection into it. We labeled it as a 3-leg stop controlled intersection. We called it a rural 2-lane road. It was actually a passing lane at this location. That's kind of the closest setting that we could fit. So not perfect, but fairly close to the rural 2-lane roadway environment. We put in the angle of that intersection, what the skew angle was. You can instantly see what that adjustment factor is, seeing that, okay, with this angle here, we're increasing crashes by about 15% from that baseline 90-degree angle condition. And crash data gets pulled automatically from the corridor. There were only a few crashes along it, both all property damage only or complaint of injury crashes. So limited data to go on off of just with the crashes. And because we have used Numetric for several years, we have all our crash data loaded into this tool fairly automatically. We want to see what would the adjustment be if in alternative 1, we did realign the intersection and changed from that skewer angle to just a 90-degree angle, so minus 15% in crashes, putting in assumptions for construction costs as well and the service life of the improvement. Then alternative 2 was what if we left the skew angle and just added that two-way left turn lane like the designers want to do with the original design variance. And we'll see a little bit of a stronger crash reduction factor for that two-way left turn lane construction. Construction cost is higher for this two-way left turn lane, though, putting in those costs from the concept report. And then alternative 3 is what if we did both of these together, correcting that skew as well as adding that two-way left turn lane as proposed in the project. With the tool, we were able to calculate expected crashes here, so weighing together both observed and predicted to add in a little bit more data to the decision-making process. rather than just the limited couple of crashes that were occurring. It's a low volume two-lane roadway, really trying to be more proactive. So you can see the expected crashes in the no build, and then all three alternatives having a slight reduction in crashes comparatively, with the most reduction being seen from that two-way left turn lane improvement and the most from the two-way left turn lane and the realignment. And we can look at that in a dollar value. Everything we do tends to go back to a dollar value. Really critical for us to put everything's in the same units. So you'll see that safety benefit of just the intersection realignment and using our crash costs, safety benefit over the 20 years of the two-way left turn lane, and then the safety benefit of them combined together. And you do get the most safety benefit from the two-way left turn lane combined with the realignment. But then what we use for most of our decision making is benefit cost ratio. So once you start looking at this, you see fairly low benefit cost ratio for just the intersection realignment, and the highest benefit cost ratio for just the two-way left turn lane. So that intersection realignment wasn't adding enough benefit to kind of compensate for its costs, and leading that two-way left turn lane alone to have that highest BC, and then allowing us to leverage this for that that design variance rather than that kind of just vague and little subjective analysis that was done previously. This analysis altogether, it took about 20 minutes per intersection. I tell the roadway designers they can charge an hour or maybe two for this. 20 minutes might be a little bit of a stretch, particularly if cost calculations brought into it. But a lot of what stems from that is crash data is automatically pulled. Data on the roadway is automatically pulled as well because we have that embedded into the Numetric platform. So attributes such as ADT and functional class were already there. And once you've entered the data in one of the alternatives, it can automatically be pulled into the others just with some slight modifications for those specific improvements. So all in all, back to those three key takeaways, the alternative analysis tool allowed us to be less subjective and be more data-driven with some of these decisions with design variances. We're able to calculate a benefit cost ratio, not using just the small number of observed crashes, but actually leveraging predictive data as well to be more proactive. And the efficiency to complete the analysis really makes this more robust and scalable and not too much of a burden for our designers to complete those design variances. And it's a tiny presentation, so that is all I got today, guys. Any questions you might have, or Craig, if we want to open up now or turn it over to Mon.
Yeah, we'll I think we've got a couple questions that have been coming in. I think we'll kind of bank those and circle back to them a little bit at the end. But thanks, Ron. I really appreciate that. I know you guys have been doing a lot of work with alternative design and specifically getting it kind of adopted and starting to have conversations in the context of these alternative designs. So it's great to have you kind of walk us through one of those examples. And it's always good to see how it's actually working in the real world as opposed to in theory. So thanks for running through that, Ron. Vaughn, we'll go ahead and pitch it over to you now.
All right. Well, I am not an expert at presenting on Zoom, and I don't know how to get rid of the top toolbar if you're seeing that. So
yeah, I think you're good.
All right. So I am not going to go into a lot of detail on using the alternative design software. I'm not an expert on using it. I rely on our designers in the regions to do that. I'm going to go into why we're using it and how we're applying it to our projects to help us make decisions. What initially started this, back in 2023, FHWA sent out a memorandum saying that we could develop our own standards and procedures for 3R projects. And this allows us to customize that program to meet our goals, and to produce a better product for those projects. It also stated that if we don't adopt a different procedure or design standards, that we had to use new construction standards on those projects. And I don't know about other states, but for UDOT, that would completely destroy that program. There's no way we could meet full new construction or reconstruction standards and still meet the goals of what our 3R program is intended for. So we had to come up with a different process. And I didn't want to just come up with a different set of standards, different minimum standards to follow. I wanted to make this a better process to meet the goals of UDOT. And so I started with what our goals and mission are for UDOT. And this helped me understand that we need to focus more on the users of the roadway. Have it a people-driven focus versus a standard-driven focus. We're not trying to just deliver a program to spend the money. We're actually developing a roadway system that meets the needs of the traveling public. And sometimes there are established nominal values restrict us, and they hold us back from meeting those needs. And so I wanted to develop a process that didn't hold us back, didn't handcuff us to some standards that may not meet what we need to do. UDOT has also adopted the safe systems approach. I don't think everybody at UDOT fully understands what this means, or how to use it in their job decisions. My plan with the 3R program is to show that this strategy on a smaller level can be successful, and then apply it to bigger projects and expand upon that. So by making it work with 3R projects that are typically $2 to $5 million projects, we can demonstrate that benefit and expand it to all projects. In order to make it work on low cost or low budget projects, we had to come up with low cost, high benefit improvements. So things that correct the speed limits on roadways. We have a lot of development. We're a fast growing state. A lot of our rural roads are quickly becoming urban roads. And the speed limits aren't changing to adapt to that. And so we need to look at that and correct the speed for the roadway given the context of where it is. Cross-section reallocation. We're finding that our standards for new construction are overbuilding our roads, potentially causing safety issues by encouraging speeding. With tools like the alternative design software, we can understand the impacts of reducing lane widths. And most of the time when we go from a 12-foot lane to 11-foot lane in an urban area, there's very little impact. But it does have impact on drivers' choice of speed on that roadway. Other inexpensive upgrades, we can do bulb outs, just striping changes. We can make significant improvements on the roadway for very small dollar amounts. And we want to look at maximizing the value instead of just meeting a standard, because the standard doesn't tell the full story and we don't understand the full impacts of that. When I first brought up this acronym here, I had a coworker that raised his hand and says, "Does that stand for peanut butter pretzel dip?" And I know it's lunchtime for a lot of you, so I thought this slide would be taunting or wake you up a little bit. But this acronym stands for performance-based practical design. And this is the approach we wanted to apply to our 3R projects. I don't know who told me this, but someone defined performance-based design as build the best transportation we can afford. There are always limitations to a project. We don't have unlimited funds. So we have to understand where to apply those funds in the best way we can to maximize the benefit for the traveling public. So if you're on this call and you were the one that told me this, thank you. I've used that to help others understand what performance-based design is, and it helps them understand that. In trying to explain performance-based practical design in this attempt to implement it on our 3R projects, I've tried to stay very high level and make it easy to understand for people that don't even know that we have these analyses we can do to predict the performance of a roadway. So I try to say, context is just the surrounding area. It defines the needs of the roadway, and it sets a level expectation for what the roadway should look like. Oftentimes, local governments, cities, counties, they have a different opinion or perspective of what a road should be. When we set the context and define that, it puts everybody on the same playing field, or the same level of understanding of what that road needs to be. So context is a very important part of this. Data-driven. We've been using the same standards to design roads for decades, 50, 60, 70 years. How our roads, cars, and behaviors have changed, we're still using the same standards. So we need to look at current data and make our decisions based off that. Data takes away the emotion and helps define possible outcomes for the problem. Helps us to make better decisions. And we need to be flexible. Every project has different limitations, funding, right-of-way, different needs, different users. A set standard rarely meets the needs of all those different aspects of a roadway. Performance-based is not just to reduce cost. We're looking for the highest value, the biggest bang for our buck. Oftentimes when I bring it up, project managers, they're under tight restrictions for schedule and budget. And so they want to look at how do we reduce cost? And that's their only goal. And that's not the main goal of this. Cost is an important factor, but we need to keep focus on what we're doing. In Utah, our 3R program has been primarily a pavement-focused program. That's a hard habit to break. These funds are not just intended to rehabilitate the pavement. We need to focus on the whole roadway and making it what it needs to be now that some time has gone by from when it was first built. The hardest struggle with this is that our pavement group has a very good system in place to program their money. They use performance-based design when they do their pavement design and their structure. They understand how to project it out and predict how long that pavement treatment is going to last. And they're very good at it. And when I come in and say, hey, we need to look at other things, it doesn't go over so well. I'm not the most popular person in the room. But my goal is not to just take their money away. It's to provide the best roadway system for the traveling public. Oftentimes with our rural roads, these 3R projects are the only time we're going to touch them. We're never going to go back and do a full reconstruct or redesign of that roadway. I think FHWA's memo made it clear that we need to focus on more than just the pavement aspect of these projects. Performance-based design is not a new concept. It's been around for over a decade. We have many resources, NCHRP projects, reports, FHWA publications, the Highway Safety Manual, and soon Green Book 8 will all incorporate. These are all resources we have that we can use to incorporate and use performance-based design now on our projects. Some performance measures that we're looking at with our 3R project is speed management and how we define design speed versus target speed versus operational speed versus posted speed. My goal is to make these all equal and just have speed, roadway speed, and have it all the same. There are a lot of struggles with that and challenges, but we're working through that to try to define what that means. Operations, we can do, adding a right turn lane or a center turn lane that improves operations and increases the safety of a roadway at a very low cost. Safety, one of the biggest things we're finding out on our projects is just adding rumble strips improves the safety at a very minimal cost to the roadway. And also, how do we incorporate multimodal facilities and accessibility without blowing the budget of the project? We have lots of tools in order to do that. Like I mentioned before, just narrowing the lanes to provide additional space in the shoulder is a near zero cost, but it provides a great benefit to the biking community. I'm sure I see some of the panel members for the Green Book 8 rewrite are on here. Without going too much into what Green Book 8 is, I want to go into what Green Book 8 will not provide. It is true that Green Book 8 is taking a big step into performance-based design, but it will not give us everything we need to integrate performance-based practical design into our state DOT policies and practices. It will not tell us when a performance benefit warrants funding for an improvement on a roadway. It will not tell agencies how to integrate context classifications into your project delivery process. It will give you instruction on how to perform the analyses and come up with the data, but each state has to come up with their own way to integrate that into their systems. And that is something that I don't think a lot of states understand. That Green Book 8 is not going to solve this for everybody. It's just going to provide another tool to integrate it, but we need to come up with how each state is going to do it. At UDOT, we're exploring how to establish these performance measures with our 3R projects instead of using nominal values provided in manuals. I wish I could share more on this. It's just not ready yet. I don't have the blessing from our management to share it out yet. I'm hoping that will be done. I will have that permission by October when we have our Utah Transportation Conference, and I'll do a session on that to share what our new process is and educate our industry on here in Utah on how to use that. So instead, I'm going to show how we're using the alternative design software tool to justify and document design exceptions for these 3R projects. We need a simple, quick way to do this because if I require too much, the projects just don't want to do it at all. And so they tried to avoid it. And I think that is a bad decision. So I want to work with them as a partner to make it easier for them to provide that documentation and make the right decisions on projects. Now, some concerns we've had come up with this is legal liability. It's very easy to point to a manual and say, look, the standard is this, that's why I met that. It's harder to justify a design decision if it's different than a manual. But if that information is backed up by engineering data, that holds the same weight in court. Engineering judgment is defensible in court if it's backed by data and it's not just someone's opinion. Second concern is no one wants to contradict the standards. Green Book is the one that everybody always cites, but in Chapter 1, it encourages design flexibility. Tells to use performance-based decisions more than nominal design criteria. A lot of people just haven't read Chapter 1 in the Green Book. So if you haven't, I encourage you to read that, because we already have adopted standards that allow us to do this process. Number 3 is the fear of changing the goal of program funding. Like I said earlier, my goal with the 3R process is not to take away their funding, but to decide where it best benefits the public. I often tell our pavement group, when does a safety improvement become more important than a lane mile of pavement, for example, to help them understand the comparison we're looking at. It may be more beneficial to the public to reduce crashes and shorten the length of that particular project. And so we need a way to compare the two. That's what we're trying to establish with our goals and performance measures for the 3R. And fourth is it takes too long to do the analyses. The HSM analyses, when you hire a consultant to do it, it's always 3 days. And with the tool of this alternative design software, we can shorten that down to just hours. We can run the different comparisons and get the data we need to make a decision. And it's available to those consultants. So when we bring it up to them and say, here, you can use this, it's free, you don't have to pay anything for it, doesn't cost the project anything. It's been very popular with the PMs to reduce that time from 3 days down to just a couple hours. And the earlier we can do that in the project, the easier it is to implement those changes or make those decisions. So we're trying to push that narrative that we need to do these analyses early in the project so that it doesn't impact the schedule. So the next few slides, I'm going to go over just some comparisons on some projects we've done, 3R projects, and what the ultimate decision was based off the data that we had. It doesn't have all the data, but this is the data provided from the alternative design software, and other limitations and information may have influenced the final decision. On this project, this is just a simple mill and fill project. And these are 4 different alternatives they were considering. For this project, they looked at widening to full standard shoulders. I think this project already had 5 or 6 foot shoulders out there, so they already had some shoulder, but it did not have rumble strips. And so then they did their analysis. They looked at just building the full shoulder, just adding rumble strips, consolidating driveways, and doing all of those things for the full build. And this shows the benefit of just adding those rumble strips. It's a very inexpensive fix or improvement. So it provides a very high benefit to cost ratio. You can see that consolidating driveways also provided a significant BC ratio, but consolidating driveways is not always a popular change for the people that use that roadway. So that one was eliminated. You can see the benefit cost of implementing the full build, or the benefit improvement provided was significant for the full build. But when you incorporate the cost into that, the BC ratio is much lower. And so this project decided to run with the install rumble strips and maintain the existing shoulders. In the next slide, you can see the expected crash reduction on this roadway for the different fixes. And we expect to see the highest reduction in crashes for the full build, but for the cost, it didn't warrant the benefit we were getting. And so rumble strips was the decision on this one. They installed those to improve the safety of the roadway and stay within the budget and maintain the schedule for that project. Another project used this tool. They were going from 6-foot shoulders comparing to an 8-foot shoulder, which is the standard on this roadway. As you can see, the BC ratio to get full 8-foot shoulders is very low. It's kind of beyond the point where we see the big increases in safety benefit when you go beyond 4 or 5-foot shoulders. So going from a 6 to an 8-foot shoulder just didn't make sense. Same with the reduction in crashes. There is a expected reduction in crashes for 2 feet of extra shoulder, but it did not warrant the extra cost to put that in. So the project decided to maintain the existing shoulders and just document that with a design exception. This project was typically not a 3R project. It was just a simple mill and fill. But the road was so deteriorated that the edge of the roadway was breaking off. So they wanted to convert their 12-foot lanes and 1-foot shoulder to 11-foot lanes and 1-foot shoulder to minimize the acceleration of that pavement failure at the edge of the roadway. And I don't know how other states handle this, but if a preservation project changes any of the geometry and it doesn't meet standards, then we require them to document that with a design exception. So if they had just maintained what was existing on this roadway, they wouldn't need to document a design exception, but because they wanted to narrow the lanes, it required them to document that decision with a design exception. So I had them do 4 comparisons using the alternative design software, just so we had an understanding of what impacts we were causing to the roadway and what we could do or potentially consider to make those impacts less. And as you can see, just reducing the lane down to 11-foot lane and improving the shoulders enough to add rumble strips produced a significant benefit to cost ratio of 5 to 6, 5.6. In fact, all of these produced a pretty good return on investment for those. This project, because of the budget and the schedule that had already been in progress, I didn't find out about their decision until a week before they wanted to advertise. So they were anxious to get this out. The road had been, it was falling apart, and they were looking for just a few-year fix with this chip seal. So they made the decision to just narrow the lane and not install rumble strips. So even though the data shows that probably is a good idea to make the improvements to add the rumble strips, they took note of what is needed on the roadway for the next project so they can budget better and make the scope what it needs to be to implement these safety improvements. But this project documented the data and made the conclusion that with this project, they would not seek to make those improvements. With these tools that we have, the HSM and the alternative design software, they're not decision makers. They don't tell us what to do. They provide the data that we can use to make an engineering judgment and to make decisions on. And that's the key part of this. When I bring this up to people, they're always concerned that the software is going to tell them what they have to do on a project. And I have to reemphasize that no, we are still engineers. We're still making those decisions. This just gives us the data to be able to make better decisions. So we're making the decision for a reason and not just because we ran out of money or we're out of schedule. We actually have data to back it up. Another project already had 5.5 to 6.5 foot shoulders and 12.5 foot lanes. And the standard was 8-foot lanes. And so they did an analysis to compare the existing to a proposed 12-foot lane with 8-foot shoulders. And it came back with a very low benefit to the cost to get those additional feet in the shoulders. So the BC ratio was 0.03, very low. So they used the alternative design software to justify their design exception. And this is a quote right from their documentation, stating that a safety analysis was completed using the AASHTOWare Safety Alternative Design tool to assess the 8-foot shoulder. And using that data, it provided all the information we needed to justify that design exception to just maintain the existing pavement width and restripe to a 12-foot lane and a about 6.5-foot shoulder with rumble strips. This picture is just to show you that Utah is a great place. We have a lot of diversity and a lot of different roads. Most of our lane miles are rural roads. But most of our population lives in very dense urban areas. Our roads serve a very wide variety of users. Rigid standards can limit our ability to make the best design decisions for our customers. Performance-based practical design empowers our engineers to make better decisions. We have the HSM, Alternative Design Software, NCHRP reports, and the Green Book as resources and tools to help us use this process. We just need to start implementing it and looking for ways to use it and not rely on our traditional nominal values that we're pulling out of tables. I always tell people that using a standard should never be the deciding factors why we chose a dimension. There needs to be a reason we chose that. And if our reason is just because it is the standard, then we're not looking hard enough. Those standards may not fit what we want, and we may be wasting money trying to meet those standards. It may be overbuilding our roadways. Money we can use elsewhere to improve the safety and save lives, which is our ultimate goal. So I hope everybody can use some of the things we're doing here in Utah and just start using this strategy and these tools to make better decisions. And, you know, if you're the black sheep in your department that says we shouldn't follow standards, well, good, I encourage that. So thank you for letting me present today.
Awesome. Thank you, Vaughn. Great presentation. I love the that idea that the standard is not just the shrug your shoulders and follow it, right? Like every decision needs to be intentional and data informed, and there has to be a reason why you're making that decision. And then also that concept of like, hey, this isn't just this tool doesn't just tell you do X, like it provides that data. And then you as an engineer need to determine, okay, given the constraints of our budget and the potential other projects we could be doing, big picture, what's the best approach to take? So I love that. I think it's a great reminder every time we start to look at individual projects, but also these processes and concepts at large. So great, thank you. We have got some great questions that have come into the chat, and Vaughn, being as you're already in the hot seat, I'll just go ahead and fire away with some of these questions directed at your presentation. Josh asked, what have been the challenges with adopting the use of these tools across your agency, and what have been the successful strategies to overcome those challenges?
So I've had people tell me that this is voodoo. math because they don't understand it. And the biggest help with that is to relate it to what they're already doing. So our pavement group is already using performance-based design to predict a lifespan of their pavement design. So I liken our approach to their approach and say, you're already doing this. You're using past data to project into the future. This is the same thing. We're using past crash and geometric data to project a predicted or expected outcome into the future. And it's the same with our operational values. We're very good at predicting traffic numbers into the future and level of service. Well, this is very similar to that. We're using data that we have that we can see and collect and projecting that into the future for an expected outcome. No, we can't know exactly what that's going to be. We don't have a crystal ball. We can't see the future. But just like these other groups and their performance-based approach, it's just a different set of data and a different projection that we're looking at.
I like that. Because again, it's not a new concept, right? Like it feels weird in this context, but like we do that all the time. Like we always make decisions in the future based off of what happened in the past. So that's a great kind of best practice to share there. This one, well, here, let me hop around. So Scott asked, kind of for a comparison. So is this alternative design tool similar to the recent NCHRP 876 tools to guide 3R safety? Um,
I think it is. I'm not sure how they developed those, but Doug, what's his last name? Doug Harmon, I think. He developed that NCGRP report and those tools, and I think he was also working with the HSM on the performance analyses. So it's very similar, but I tried to figure out those spreadsheets and I couldn't do it. I'm not a safety engineer. I'm not an HSM expert. I could not figure out how to use those, which is why I was so thrilled when Danny came to me with the alternative design software, because it's an interface that I can use and I don't have to understand all the background math and where they're getting all the data. I can put the things in that I understand and get the results that I'm looking for.
that's awesome. And someone chatted in Doug Harwood is
Doug Harwood, yeah.
Um, all right. This question is kind of for Vaughn and Ron. Has either Georgia or Utah required the use of alternative design to support all design exceptions or the 3R program yet, or is it still used on an as needed basis? So, Vaughn, I know you talked about that a little bit, but
So we do not and we will not require it. We provide it as a tool. I know several consultants have already developed their own tool based off the HSM analyses. They're welcome to use those. We see this as just an available tool that is free to consultants, internal staff. Projects can use it as they want, but it is not needed. We do often require the analysis to be done so that we have it's our best way to predict the impact to the traveling public as far as safety impacts. So we do require it on some design exceptions, but it is not the ultimate decision maker, and we just use it as a tool.
thank you.
About the same in Georgia here as well. It's a tool available. That makes it easier.
Ron, being as you're talking, we had a couple questions come in, and Ron dropped those answers in that Q&A window, so you can go in and kind of check those out. But I did actually, Ron, want you to kind of answer one of them or a few of them so that everyone can hear it. The question did come up around in fact, we had two questions come up around, your reference of the twiddle, the two-way left turn lane at that intersection. Can you just kind of describe a little bit
Sure.
around how you kind of resolve that, being as that's not an intersection?
So we did a little workaround there. We used the left turn lane. Huge difference, I suppose. But yeah, at an intersection, the two-way left turn lane functions as a left turn lane. So that's the CMF that was used in this one, and that from the HSM. Um, Lots of different crash reductions tied to that. A couple of people asked about, well, did we read the crash reports to, I guess, manually correct them and see if they're correctable? Couple of things with that, these crash modification factors are not 100% for a reason. They're the CMFs include non-correctable crashes in them. So I do think it's important to include those. If it's reducing 40% crashes, you're reducing 40% of correctable and not correctable crashes. But then there's other CMFs like protected left turns that are specific to this left turn opposing through crashes it signals. So if you're applying this for something like that, yeah, that's where it's a lot more important to read those crash reports and remove them from the analysis, or only include certain crash data that's relevant to the countermeasure if you're tying the CMF to a specific crash type. There was something in the chat about is 20-year analysis too long as well? I would say no for a left turn lane. Those will be there probably far longer than 20 years. That's pretty standard for us on these countermeasures. Like all of our long-standing countermeasures, we use 20-year service life versus something like pavement markings that's going to fade. We'll use the 5-year countermeasure, 5-year service life for that one.
Yeah. And I know that service life is a variable. So, depending on what specific improvements are being analyzed, you can kind of customize the length of time. I know in UDOT, like pavement markings, snow, salt, scrape, like the snow plows.
Maybe only 1 year and you die.
Yeah, it's rough. Well, I guess we have to have a winter first, though. So, but anyway. Another question came in, and this is kind of, I apologize, Connor. I'm going to kind of tweak the question just a touch. So if you feel that I've ruined the essence of your question, drop it in the Q&A window again. But Connor asked, how well does this tool handle unknowns? And I want to kind of modify that a little bit to say, like, how well do these practices and concepts, right? These alternative design concepts, the models in the HSM, how do they handle unknowns? One of the common issues for their department is VRU crashes. They frequently don't have good models or counts for VRUs and predictions on future use. A good example is one of the current projects adding a sidewalk where there isn't one will increase safety and usability, but we don't have any good data to support that. So kind of in the absence of data, how can these models and these tools be used to help inform those decisions?
So this goes back to the individual agencies deciding how they're going to handle it. The software may not be able to tell us much information on this, as he pointed out. There are some comparisons and trade-offs that we're not going to have direct comparisons for, but we need to make sure we account for the vulnerable users and make that facility a safe one for them to use. And I think context classifications is where we're going to see the biggest improvement. If we define what the roadway is supposed to do and function and provide service for in a certain context, then it's at the forefront of the decision making for that project. So they start the project looking at those elements, and it's not an afterthought. And I always think of this as the softer side of Sears, right? There's no hard data that says we have to put in a sidewalk when we meet this threshold. We have to have policies and guidance for our designers so that they can make the decision of when to fund those. And that has to happen at the agency level to determine what their comfort level is and how they want to fund those.
I'll say with this one on BRUs, not I think we're looking at those HSM2 models to be included in this in the future. I'm not sure if the platform leverages that just yet, but that is something we're excited about. But right now, when I guess it says in the question, we don't have any good data to support that. Having data is important, whether it's counts, whether it's ridership at bus stops, whether it's land use. I use what data we have available to prioritize and invest in different locations. So if there isn't good data to support it, I would question why you are programming something there, unless it's a part of another project. In Georgia, we have our complete streets warrants, so we would actually have to use a tool like this if it was in a certain context where those complete streets warrants are met to justify not using and not incorporating the sidewalk, because the baseline is if you're doing a project here that's widening the road, adding turn lanes, things like that, you have to provide the pedestrian accommodations. So there'd have to be a data-driven reason not to include that.
No, great answers and great insight. I love the unique perspectives from, we all have the different agency constraints. It's great to kind of hear the different perspectives from Utah and Georgia on that. And Ron, you did touch on the HSM2 models and calculations being included. Those are currently incorporated into the alternative design. So we do have the ability to kind of support those. And that was something that was important, was having that scalability, not just because HSM2 has perpetually been 6 months out for the last 3 years, but because there's always changes, there's always more research, there's always new studies coming out. So having that ability to kind of support those new, data points, those new formulas was really kind of central to the design. So glad you called that out. Well, we are